Welcome back to part 11 of our DIY Autonomous Mobile Robot Building series. If you missed any of parts 1 through 10, check out the links in the description below or access the full playlist at the end of this video. In part 10, using Fusion 360, we made significant progress in the chassis design. Today in part 11, we'll continue refining the chassis design and take it one step closer to completion. First, let's improve visibility by hiding both left and right wheels. Instead of using glue or cement, which usually don't adhere well to HDPE, we'll bolt the walls and bases together while incorporating joinery methods. Edit the sketch on base 1, press P for project, and select the outer edges of the left and right outer walls. Design a rectangular protrusion or connector tab 4mm from the front end so that it is flush with the outer surface of the outer wall and has a width of 7mm. Then connect the open end back to the base again. Add a distance of 7mm and sketch out another rectangular protrusion with the same dimensions. Mirror these protrusions by selecting each line segment we sketched, select the center line of the base and hit OK. Then finish sketch. Now before we extrude these rectangular protrusions, we should hide both outer walls. Select each rectangular protrusion and zoom in to select the portion of the protrusion that includes the clearance between the base and each outer wall, and extrude by 3.7mm while making sure the operation is set to join in the extrude palette. Now the rectangular protrusions are perfectly formed on both sides of the base. Activate the entire design at the top of the browser. Now we'll design a tab for preventing the battery holder from dropping down. Select the face on the underside of the base and create a new component. I've labeled the new component Battery Pack tab. Create a new sketch. Select the rectangle tool. Select center rectangle from the sketch palette and sketch a rectangle centered on the origin with 25mm. Hit the tab key and enter a length of 40mm. Select the circle tool and sketch a circle centered at the center point of the right side of the rectangle and snap it into the corner of the rectangle. Use the cutting tool to remove the left side of the circle. Put in a left center line. Here I added a 2.1mm hole at an arbitrary position on the center line, but that should have been a clearance hole of 3.2mm for an M3 screw to fit through. Anyway, this circle is not yet constrained. I also made a copy of this little circle as I want to fasten the battery holder tab at 2 locations to prevent the battery holder tab from rotating. Use the measuring tool and set the distance from the left side of the battery holder tab to 8mm and the distance between the 2 holes to 8mm. Finish sketch. Swivel the design, select the extrude tool and extrude the entire shape of the battery holder tab except the 2 holes. Activate the entire design again. Let's round the front corners of the battery holder tab. Select fillet and enter a 5mm fillet. But don't hit OK yet, hit the plus icon, which allows us to do a separate fillet on the same body. So let's select the underside of the battery holder tab and enter a fillet amount of 0.2mm and do the same for the top surface. Now activate base 1, create a new sketch and select the underside of the base, press P to project and select the 2 holes of the battery holder tab. Here I am sketching 2.1mm holes on the base, which is the actual pilot hole diameter for an M3 metric thread. Tilt the underside a little and we need to hide the battery holder tab and then form the 2 holes through the base by extruding into the base by 3.7mm. Activate the entire design again and unhide the battery holder tab. Before we carry on, I think we should gather all the servo grommets together under a single component folder. Create a new component, label it grommets. select all the grommets and drag them into the new grommets component folder. I did the exact same thing with the eyelets as well. Now let's make some M3 washers for the battery holder tab. Create a new component and label it M3 washer. Activate the M3 washer on the browser. Create a sketch. I selected the undersurface of the battery holder tab as the sketch plane, but anywhere would be fine. Sketch a 3.2mm circle on the origin and an outer diameter of 7mm for the particular washer I'll be using. Extrude the washer by 0.5mm. Hide the battery holder tab and hide base 1. Now select the entire washer and apply a fillet of 0.1mm. Press A for appearance, and I selected a black metal oxide coating for the color of the washer. Unhide base 1 and the battery holder tab. Select joint from assemble. I didn't need to swivel the design around to select the other side of the washer, but that's what I did in the footage. Press the control key and select the central snap point. Swivel the design back to the underside. Unhide the base and the battery holder tab. Select the central snap point of one of the holes and hit OK. Select the washer from the browser. Select the copy tool and check create copy. Move the copy to an arbitrary position and hit OK. I also used joint from assemble to attach the washer onto the underside of the battery holder tab in a likewise manner. I labeled each joint M3 washer to battery tab. Now let's use insert to add an M3 screw to the design. I selected a round head screw size M3 with a length of 8mm. The screw appears here with the move tool already activated. Move it into position and hit OK. It has vanished, so let's look for it. So with the underside of the head of the screw visible, create a joint by selecting the center snap point on the plane of the underside of the head of the screw, and then selecting the center snap point on the plane on the underside of the washer. I labeled this joint M3 screw to battery tab. Create a copy of the screw and attach it to the other washer in the same manner, and unhide the battery holder tab and the base. Now let's zoom in to the top surface of the base, and we can see that the end of each screw is flush or approximately flush with the top surface, confirming that the length of 8mm for each screw was the right length. Once the robot is fully assembled, we won't have access to the top surface of base 1, so that's why I decided to thread each hole for the M3 screws to screw into. Swivel the design to the top view and hide the Arduino. Create a new component and label it base 2. So we are designing a second base for our robot chassis. Activate the component and hit OK. Zoom in and select the top of the washer that is on the caster wheel and create a sketch. Press P to project. Select the bolt diameter of the caster wheel assembly. Select the inner surface of the right inner wall, and likewise select the inner surface of the left inner wall. Also, select the rear inner surface of the right inner wall. Select the outer surface of the wall that constitutes the right battery rear hook, and likewise for the left inner wall and the left battery rear hook. We also mustn't forget the outer surfaces of the left and right inner walls. Hit OK and create a 6.2 clearance hole centered at the center of the bolt of the caster wheel. Select the line tool and connect the two ends of the inner wall. Let's sketch a construction line from the center of the circle to a distance of 73mm. From that point, sketch a line at right angles to the right inner wall, then sketch in the rear direction along the inner wall by 8mm. Sketch a line outwards by 3.7mm, the thickness of the inner wall, then an 8mm line extending rearwardly along the outer surface of the right inner wall, a line extending inwards back to the inner surface of the right inner wall, giving us a first 8mm wide tab. Sketch another 8mm wide tab starting 16mm behind the first one. After that, from the rear side of base 2, sketch an 8mm line forwards, then sketch an outward line, this time to the outer face of the battery rear hook. Sketch a 16mm wide tab, then a line back to the inner wall surface, and a line to the second 8mm wide tab. As we can see, this sketch is fully constrained. Select Mirror from Create and select all the line segments we have just created and the central construction line as the mirror line and hit OK. Finish sketch, select the Extrude tool and extrude all the portions of base 2 by 3.7mm. Activate the main design again, swivel to the side view and unhide outer wall 1. So let's select the outer face of the outer wall and create a new sketch. Press P to project and project the shapes of the tabs of base 1. Next, select the offset tool, select the rectangular shape we have just projected and set the offset to 0.2mm. Zooming in, we can see a slightly larger rectangle surrounding the projected rectangle. Do the same with the other rectangular tab. Now finish sketch and extrude these shapes as holes by cutting through by 3.7mm. I also did the same for the tabs that protrude from base 2 through inner wall 1, which automatically forms corresponding rectangular holes in inner wall 2 as well. Also, I formed a corresponding rectangular hole in each battery pack rear hook using the same technique. So there we have base 2 with its rectangular tabs fitted into corresponding rectangular holes in the inner walls and the battery pack rear hooks. Hide the left inner wall so that we can see the side of the 9V battery. There's a slight gap between the underside of the 9V battery and base 2, so let's use the move tool first and move the 9V battery upwards to an arbitrary position. Next, use the Align tool and select a snap point, which is at the center in the lateral direction, on the underside of the 9V battery, and then select the top surface of base 2. The 9V battery glides onto base 2 to come into contact with base 2 so that there is no gap between the two. I'll just unhide the right outer wall. You may have noticed this part inside the slot formed in base 1, which appears to have been left over from when I formed the slot for the circuit board. I unhid the sketch on base 1, selected the leftover portion and extruded it out. It looks like I have lopped off two rectangular tabs by accident when I extruded the rectangular holes in the left outer wall, so we'll just quickly extrude new ones from the original sketch of base 1. Let's also color base 1 white again. Let's also unhide the circuit board and the right outer wall. Create a new component and label it board guard. Actually, before we carry on, I need to center the lateral or left-right position of the circuit board. So I'll move the circuit board to the right by 2.25mm divided by 2, since the circuit board was offset to the left by that amount. While we're here, let's unhide the body shell and select section analysis from the inspect menu. Select the front plane and move it back by -1mm. Now, although the circuit board is aligned correctly in the lateral central position, the slot in base 1 was mistakenly formed when the circuit board was out of alignment, so we'll need to fix the slot at some stage. Anyway, let's adjust the vertical position of the circuit board by using the move tool and moving it down by -6mm. Now here you can see I have removed the slot for the circuit board from base 1 because the slot was not aligned correctly. I have also removed the left and right slots as I had second thoughts on whether they would actually be necessary. Select the rear surface of the circuit board and create a new sketch. Let's hide components that obscure our view of the circuit board and hide base 1 as well. Project the outer edges of the circuit board and the holes for fastening the circuit board. Select the inner and outer edges of each outer wall. Hit OK, unhide base 1, select the rectangle tool and create an initial rectangle that surrounds the outer side of the wires. We need to design some projections that are to be inserted into the outer wall. walls. So we'll start from 8mm down from the top, sketch a horizontal line from there to the outer face of the outer wall, give the projection a 12mm vertical thickness, and sketch a horizontal line back down to the main body. From there, sketch a 20mm vertical line downward and sketch another projection in the same manner. Now we want to fill in the space between the two projections, so let's sketch a line between the two projections, parallel and close to the inner surface of the outer wall. Use the dimension tool to set a distance of 0.2mm between these lines. Now we need to mirror these newly sketched lines to the right side, but first let's sketch a vertical construction line through the origin. Then we can select these lines as objects and the vertical construction line as a mirror line, and we can hit OK. Next, we want to design some slots to allow wires to go through. Sketch a construction line between the two projections and constrain it to 2.5mm from the main body of the board guard. Now create a center-to-center slot defined at each end of the construction line and dimension the half width of the slot to 2.5, which constrains the whole slot. Then likewise mirror that slot about the center line. There's a few white patches on the right side of the profile, so I'll just sketch in a few more lines and that did the trick. Finish sketch, select extrude and the various parts of the board guard. Since the plane lies on the circuit board, all the holes of the circuit board show up, so I'll just select all those as well. And here I have extruded the board guard by 3.7mm. Now we can unhide components. It looks as though the battery pack tab has moved down some distance from base 1 for some reason, so I'll need to put that back by using the joint tool. And there it is back in its proper place. Let's hide the left outer wall for better visibility. Zoom into the rear side of the board guard. Press A for appearance and color the board guard white. Unhide base 2 as well. Now that the circuit board has the board guard attached to the rear side, we can now form a wider slot in base 1. So activate base 1 and create a sketch on the underside face. Press P to project, select the periphery of the board guard and the circuit board too, and hit OK. Next, select the offset tool, select the outer perimeter defined by the board guard and the circuit board, and create an outwards offset of 0.4mm. Next, we need to use the extrude tool to form the slot. Hide the circuit board and the board guard, select the slot and the surrounding offset section, and extrude by -3.7mm to form the slot. Activate the main design again. Upon measuring the distance from the slot to the front edge of the battery pack tab, it was almost nothing at 0.009mm. However, we'll need to widen the slot later to allow for a rear cover for the board guard, so we'll need to shorten the battery pack tab a little. So let's unhide the sketch for the battery pack tab and edit that sketch. Let's change this dimension from 40mm to 38mm and finish sketch. Hide that sketch, and there we have the battery pack tab with its size adjusted. We should also take this opportunity to widen the slot in base 1 to allow for a rear cover. So edit the sketch of base 1, zoom in and sketch in a thin rectangle at the rear side of the slot. Make sure the short sides of the rectangle are coincident with the short sides of the slot, and use the dimension tool to set the width of the rectangle to 0.5mm. Now that's ready to be extruded. I've skipped the footage for extruding or cutting that part, but here's the widened slot. Let's unhide the board guard and the circuit board. Zoom in to the rear side of the board guard and create a new component. Label it Circuit Cover. Select the rear face of the board guard and create sketch. We'll just hide a few components for better visibility. Press P to project. Select the entire rear face of the board guard and hit OK. Extrude in the rear direction by 0.5mm. Activate the main design again. Press A for appearance and color the circuit cover white. And let's unhide some more components. So here we have the circuit cover attached to the back of the board guard to protect the wiring of the circuit board. To continue, click here for part 12. If the link isn't showing, part 12 isn't quite ready, but should be soon. Check the description for my upload schedule. Thanks for watching.